Here in Antarctica, on the coldest and most isolated region on Earth, scientists are boring into our planet's past for clues to the future of global warming.
This is actually a very special place. It's the best place on the planet to get a record of how greenhouse gases have influenced climate for the last 100,000 years.
Ken Taylor and his colleagues at Waste Divide are drilling for ancient ice like wildcatters for oil. The camp, funded by the National Science Foundation, is named for its place atop the West Antarctic ice sheet, about 600 miles from the South Pole. From here, ice flows away evenly in every direction. The ice sheet, about 2 miles thick, is a unique chemical archive of Earth's atmosphere. Data collected from here could provide the best chance yet to pin down a puzzling problem in the science of climate change.
One of the questions everybody's interested in with greenhouse gases is, did the increase in the atmospheric concentration of greenhouse gases occur before or after the increase in temperatures in past climate changes? And ice cores are the only way we can really answer that question, because ice cores tell us both what the concentration of greenhouse gases was in the past, and they also tell us how cold it was.
Scientists here read the layers of ice like pages of a diary. Air bubbles trapped in the ice fields preserve direct evidence of the changing atmosphere during past global warming and cooling episodes.
And we can look hundreds of thousands of years ago and see what was in the air. We can exactly measure how much CO2, how much methane, how much oxygen there was in the air.
The crystals themselves contain the faint residues of gases, isotopes, and wind-borne dust that record the changing climate. This subtle chemistry charts the rise and fall of the oceans, the end of the last ice age, the eruption of distant volcanoes, the depletion of Earth's ozone layer, and changes in the winds that drive worldwide weather patterns. In a special snow pit on the ice sheet, Dr. Taylor examines how nature creates an irreplaceable climate record every time it snows.
By looking at things like the chemistry of it, you can determine things like wind speed, the extent of sea ice. Looking at the isotopes, you can determine how cold it was. Looking at that gas sample, you can determine what the greenhouse gases was. And you can determine an awful lot about the climate just by looking at or by measuring a piece of this ice, essentially.
Conditions here are usually so harsh, though, that the crew can only run the drill 35 days a year. And it may be another year before they finish drilling, and another 3 years before the ice is fully analyzed. By accurately reconstructing past conditions, they hope to settle uncertainties over the causes of natural climate changes, which bear directly on political and scientific disputes today about greenhouse gases.
We're in a completely different situation here with humans introducing CO2, but we can still learn a lot from what happened in the past in the natural system and use that information to improve our ability to predict what's going to happen in the future. So we're not really here studying Antarctica. I mean, I don't really care about the Antarctic climate. There's nobody who lives here. But I'm taking information away from here, which we're going to be able to use to improve the models that we use to predict how humans are influencing climate in the future.
Here on the ice cap, a day can last all year. The sun rises in August and sets in April. In this climb, water is a solid that flows at a glacier's pace. The continent contains 3/4 of Earth's fresh water and yet is the world's largest desert, more arid than the Sahara and colder than a Martian spring. Buried deep in this continent of contradictions may be the key to our own role in a world of climate change. At Waste Divide on the West Antarctic ice sheet, for the Wall Street Journal, I'm science columnist Robert Lee Holtz.